Hi everyone, Tina here, and today I'd like to talk about straight line graphs. In this video, I want to talk about the essential skills you'll need if you're doing straight line graphs in either the Foundation or the Higher GCSE courses. Here are the key ideas you need to be familiar with for this topic. I'll run through each idea separately and go through some examples where they're relevant. The first idea we need to be comfortable with is vertical and horizontal lines. We need to know what they look like and recognize the equations for them. For example, let's say we had a vertical line coming down here. This is a straight vertical line going down through where x is equal to 3. So the equation for that line will just be x equals 3. If you have a look at some of the coordinates along that line, for example here, that will be 3, 1. The next one up would be 3, 2, 3, 3, and so on. Hopefully you can see that no matter where we are along that line, the x coordinate is always 3. That's why it's called x equals 3. If we had another vertical line coming down straight through -4, the equation for that line would be x equals -4. For the same reasons. Let's have a look at horizontal lines now. So if I draw a horizontal line going through 5, that's specifically where y is equal to 5. So the equation is y equals 5. Again, if we look at some coordinates along that line, so for example here, that's -3, 5. This one here is 1, 5. And this one here is 6, 5. All the way along that line, no matter where you are, the y coordinate is always 5. If I draw another horizontal line, let's say down here, that equation will be y equals -2. The next idea is special diagonal lines. And by those, I mean the two lines y equals x and y equals -x. If we start with y equals x, that looks like a diagonal line that passes through some really specific points. Just going to draw the points on first and then draw a line connecting them up like this. That is the line y is equal to x. You can see why if, again, you look at the coordinates of each point. So if we've got here, we've got 1, 1, 2, 2, 3, 3, and so on. No matter where you are along that line, the x and y coordinates are the same. They're equal. So y is equal to x. If you go the other way down the page instead, so let's say you plot these points coming down and then draw a line connecting those up, that would be y equals -x. If we look at the coordinates here, we've got 1, -1, 2, -2, 3, -3, and so on. So the numbers themselves are equal, but one is the negative of the other. Hence, y equals -x. Next idea, drawing straight line graphs. Now, the easiest way to do this is to use a table of values. And sometimes they'll give you that table of values in the exam and sometimes they won't. Either way, it's fine because if they don't, you can just draw your own table and fill it in. In this example we have here, they've actually given us a table to complete. So it says complete the table of values for y equals 4x -4. First thing to notice is there's an x there and then there's a bunch of x values here. There's also a y there and a y here, and that's what we're going to fill in. The way to do this is to use the equation and essentially substitute the values of x into the equation to get the values of y. So for example here, we can do y equals 4 times -2 take away 4, because in that box, x is equal to -2. We can work this out with or without a calculator, and that would give us -12. Similarly, in the next box, we want to do y equals 4, and then this time times -1 take away 4. Again, with or without a calculator, that equals -8. Next one would be 4 times 0, take away 4, which is -4, and so on. Now, you may notice that there is a pattern in this case. The y values are in fact going up in 4s. That's useful to know, but be aware that this pattern only works for straight line graphs and straight line equations. Once you've got your table of values complete, you can use those values as coordinates on the graph. So it's telling us, for example, that one of the coordinates on the straight line graph is going to be -2, -12. The next one's going to be -1, -8, then 0, -4, 1, 0, 2, 4, and then 3, 8. And you know you've done it right because the points will look like they're going to join up with a nice straight line. And in fact, when you then use your ruler to join them up, you get a nice straight line, and that means you've done it right. Next idea is a really important one. It's about the general equation of a straight line. You'll probably hear this all the time if you're doing GCSE maths, and the general equation is y equals mx plus c. We need to know that the m stands for something called the gradient, and this is essentially how steep the line is. We also need to know that the plus c is referring to something called the y-intercept. That is where the line crosses the y-axis. We'll do quite a few examples with this idea because, as I said, it's really important. Here's the first example. So it says, find the equation of line L in the form y equals mx plus c. So I've just got a little reminder on the side of what m is and what c is. First thing I would do is write down y equals mx plus c again. And I usually start with finding the y-intercept because that's usually easiest to see from a graph. So y-intercept, where the line crosses the y-axis. In this case, the line is crossing at 3. So we can write down straight away y equals mx plus 3. Now, finding the gradient m is a little bit harder, and there's lots of different ways of doing it. So I'll mention a few ways and then I'll do the way that I prefer. Gradient m equals, one of the most popular equations to use is change in y over change in x. And that is the one that I personally use. But you might have seen it written as m equals rise over run, or even m equals y2 minus y1 over x2 minus x1. Totally depends on how your teacher has explained it. Either method would be totally fine, but I'm going to use the change in y over change in x method. So what you need to do is look at your line on the graph and pick 2 points that are easy to read in terms of their coordinates. So I would pick, for example, this one here, which is 2, 6, and then this one a bit further up, which is 4, 9. Once you've picked your points, you need to look at the change in y and the change in x. So change in y is referring to the y coordinates. How is y changing from 6 to 9? And that change is plus 3. Then you take a look at your x coordinates. So it's going from 2 up to 4. So in terms of a change, that's a plus 2. Overall, plus 3 over plus 2, another way of writing that is just 3 over 2, and that's our gradient. So at this point, you can go ahead and write down the full equation of the line for the answer, and it's going to be y equals 3 over 2x plus 3. Now, whilst we're here, it is worth mentioning about the gradient as well. When you've got a graph in front of you, another way of thinking about the gradient is starting at a point on the line, let's say the y-intercept, and then looking at what happens when you travel 1 unit across. So we go 1 across, then to get up to the next point on the line, do you notice that we go 1.5 up? 1.5 is the same as 3 over 2, and that's another way of looking at the gradient. So you can go 1 across, 1.5 up, 1 across, 1.5 up, and so on. That is useful for sense checking your work, but be aware that that method only works if you have an accurate diagram or picture of your straight line equation. Most of the time, I would say it's better to use the methods in green. Let's have a look at another example. So in this case, they also want the equation of the line. So let's start with our general equation, y equals mx plus c. Again, starting with the y-intercept because that's nice to see. It is plus 5 in this case. So y equals mx plus 5. Next, we have to find the gradient. Again, choose whichever method you prefer, but I'm going to do change in y over change in x. So I need to pick 2 points again, and I'm going to choose 1, 3 and 2, 1. This will work for any 2 points that you pick, so just choose whichever ones you think are easy to read. This time, if we look at the change in y, the y coordinate is going from 3 down to 1. So in terms of a change, that's actually a minus 2. The x's are going from 1 to 2. So in terms of a change, that's a plus 1 change. Always reading the graph left to right. Overall, minus 2 over positive 1 gives a value of minus 2, and that's your gradient value. So in this case, the full equation of the line is y equals minus 2x plus 5. Again, you can check your answer if you have a picture because you could start at the y-intercept and go 1 across and then see that you actually are going 2 down in this case. So minus 2 gradient tells us 1 across, 2 down, and so on. Now, hopefully you noticed from those 2 examples that when we had a line going up the page, we had a positive gradient. It was a fraction, but it was still a positive number, 3 over 2. When we had a line going down the page, left to right, it was a negative gradient, negative 2. Knowing that up is positive and down is negative can be really helpful for questions like this one. So in this question, we've got a diagram with 4 straight lines and we've got to match up those lines with their equations. First thing I'm noticing is that there is a nice horizontal line there, Q. That one's got to match with y is equal to 3 from the first case that we looked at earlier on in the video. So that one is for Q. Then we've got a straight line that's going up, but it's going through 0 or the origin. That means the y-intercept is 0, so there won't be a number on the end of the equation. And the one that fits that is A. Then there's 2 left. One has a positive gradient and one has a negative gradient. So that corresponds with one going up the page and one going down the page. So if we start with the positive gradient one, y equals 2x plus 3, that must be R. And then the negative gradient one, y equals 3 minus 2x, that must be P. Here's an example. A straight line has equation y equals 2 minus x, and they want us to write down the gradient of the line. Now remember, the gradient is the number in front of the x, always. In this case, it looks like there isn't one, but that's because a minus with no number is the same as minus 1. Minus 1 times x. Then write down the coordinates of the point where the line crosses the y-axis, in other words, the y-intercept. That's the number that's on its own. So in this case, 0, 2. Next example says a straight line has equation 4y minus 5x is equal to 2. Work out the gradient of this line. Now, we can't actually read off the gradient unless the line is in that specific form, y equals mx plus c. So the first thing we want to do is rearrange this so that it looks like y equals mx plus c. One way is to do the method where you do the same thing to both sides. So in this case, we could add 5x to both sides. That would get rid of the minus 5x there and leave us with just 4y. And on this side, we would have 5x plus 2. Then we're almost there, but we've got 4y and we actually want 1y. So we would divide everything by 4. And that would be y equals 5 over 4x plus 2 over 4. Now we can see that the gradient, the number in front of the x, is in fact 5 over 4. Last example in this section is quite tricky. So it says, find the equation of the straight line that passes through minus 2, 9 and 3, minus 1. Give your answer in the form y equals mx plus c. Now, the reason I say this one's quite tricky is that there's no diagram. It's just a description of the scenario. So what you can do to make it easier for yourself is draw a little sketch. Doesn't have to be super accurate, just anything that will remind you visually of what's going on can be really useful. That's the x-axis, that's the y-axis. Minus 2, 9 is roughly somewhere there. Again, doesn't have to be accurate. 3 minus 1, I'm going to put down here somewhere. And now I can see that if I join up those 2 points, that's the line that we're talking about. I know I want to give my answer in the form y equals mx plus c, so I'm just going to go ahead and write that as a reminder. In this case, it's not obvious what the y-intercept is straight away, so we can't actually start with working out what c is. We can, however, go ahead and work out the gradient, m. So m equals change in y over change in x. We've got our 2 points that we can use for this. So first of all, looking at the y coordinates, looks like they're going down from 9 to minus 1. So in terms of a change, that's a change of minus 10. And then for the x's, we're going from minus 2 to 3, and that's a plus 5 change. Minus 10 divided by plus 5 is minus 2. So that's our gradient there. So now we can say we know that y equals minus 2x plus c. Find the value of c, all you need to do is pick one of the coordinates that they've given us and substitute the values into your equation. So if I choose minus 2, 9, when I say substitute, I mean make the y 9 and the x minus 2. We can do that because in coordinates, remember that first value does represent the x value and the second one does represent the y value. After this, you've just got an equation that you can solve. So 9 equals 4 plus c means c must be equal to 5. And then you can put it all together. So y equals minus 2x plus 5. Final idea for this video is parallel lines. So as you can see here, I've drawn a bunch of lines which are in fact parallel to each other. So parallel meaning traveling in exactly the same direction and they will never meet each other. They all have different y-intercepts because they're all crossing the y-axis at different points. But do you notice that they all have exactly the same gradient? And that is the key fact here for parallel lines. I'll just write that down. So key fact, parallel lines have the same gradient. And that's it. I'll show you that idea in practice. So if we look at this example, it says a line M has the equation y equals 8x plus 3. Write down the equation of the line parallel to line M that passes through the point 0, 6. As soon as we see parallel in the context of straight lines, then we can make a note to ourselves, same gradient. What is the gradient in this case? Well, looks like there's an 8 in front of the x, and it is in that y equals mx plus c format, so that's good. So we'll use the same gradient, y equals 8x plus c, and in this case they've actually given us the y-intercept directly as well, because they've told us that the line passes through the point 0, 6. Because the x-coordinate is 0, it means that's the y-intercept, so we can go ahead and just write y equals 8x plus 6, and we're done. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else that you think might find it helpful. Thanks, and see you next time.